In this video, we are going through the full IAB 2021 grade 12 exam from start to finish without leaving absolutely anything out. Let us just dive into it really because there's really no time to waste any time. But anyways, it says you use this formula, right, which is the quadratic formula to solve for x correct to 2 decimal places. So these kinds of questions, it's literally them just giving away marks because that's exactly all that they're doing here. So everything we can take it to one side. Oh, goodness. The screen needs to be clean, man. Come on. So we can take everything to one side. We're going to have here 3x squared minus 5x. And then minus 3 equal to 0. And then we're going to have here x is equal to minus b plus or minus b squared minus 4ac. The whole thing over 2a. So all this being done, b is like minus 5. And then you have here minus 5 squared minus 4. A is a 3. C is negative 3. So with this being done, our A value is just a 3. So let's put all this in the calculator and see what we get, because we're bound to get something specific. So let's see here, minus B. No, that's like what? It's minus 5. Oh yeah. So it's like negative 5 squared. No. Wow, bro, come on. Square root of negative 5 squared minus 4. A is a 3. C is a negative 3 over 2a. There we go. Yeah, so the reason why they've asked us to use the quadratic formula is because we were not necessarily going to work this out by just doing things from our head. As in, we were not able to factorize this using normal factorization. We definitely needed this this format. So this is going to be 2.14. 2.14 is the final answer. That's okay. That is all good. Let us just carry on. Let's keep the ball rolling because we do not have time to waste. So moving on, let's see what we have there. They're asking us here to, they said hence. Any question that starts with hence, right? It's asking you to make use of the previous question. You see, they will literally be asking you to make use of the previous question. Because if you don't use the previous question, then yeah, you're gonna find yourself in a bad spot. So the reason why we need to make use of the previous question here is because if you think of it nicely, right, they're asking us where is this graph going to have y values that are bigger than 0. That's exactly what they're asking. They're asking where would the y values be bigger than 0. So a question like that, you have to visualize what the parabola looks like. The parabola here, it's a smiling graph. So because we have a positive a value, it's a smiling graph since we have a positive a value. And what we do know is there's two intercepts, right? The two intercepts, there is negative, no, this was negative, bro, come on. There's negative 0.47, right? So this is negative 0.47. And then the other one is 2.14. So all this being done, we need to acknowledge that the graph is above 0 here. You see, and here also. So there it's x values that are bigger than 2.14 or x values that are smaller than negative 0.47. Those are the x values that will produce this part here that's above 0, this part here that's above 0. So it's a 2-mark question. We can just keep things moving. The next question, oh wait, let me just write this nicely. This is a 4, my guy. It's a 4. Write it nicely. The next question says solve for x and y simultaneously for 5 marks. So nothing crazy here, nothing major really. This equation, it looks as though it's easier to put stuff in this one because this one is squared and all that. Or rather, we might as well take this. This is already y, right? And put it in there. Yeah, let's do that. So this we're going to say 2. Here we're going to say x squared plus 5x, right? And then minus 2, 4x equal to 0. Yeah, this seems like it's going to be fine because the y value here is x squared plus 5x. So the 2 you can multiply it inside the bracket. The 2 you can multiply it again. And then here you have something like what? This is just a 0 here. And then you have the here you can take out a 2, but meh, I usually just don't take out anything just because I don't want to. Like literally, I hardly ever take anything out if I don't see it's necessary. I just put it the way it is in the calculator. So this is like minus b plus minus b squared. So it's like b squared minus 4ac. Whoa. Stop. Bro, what just happened? Hey, bro, I'm literally throwing myself off because, dude, we don't have to do all this because these are like terms. Come on, man. This minus this is going to give you negative 14x. And then here you can take out 2x as a common factor. Yeah, that was awkward. I was literally just going on and on, doing something that was likely wrong. So anyways, wait. Let's see what answers we're getting here. X is equal to 7, or x is equal to 0. Yeah. So that's okay for x. For y, you can throw x in there, right? So you'll have here y is equal to 0 squared plus 5 times 0. Y is a 0. The other one, it's like negative 7, right? 7 squared plus 5 times 7. It's like 49. 49 plus 35. That's like what? 84. That's the way we like it. We got our x and our y. We're keeping things moving because that's the way we like it. Moving on, it says for 5 marks, right? So for x, if this equation is got to the right hand side. So this kind of equation, you do want to leave the stuff that has a square root symbol on its own first. And then you want to take the other stuff to the other side. The reason for doing this is you're clearly, obviously here able to take out the square root symbol by squaring both sides. So you solving for x in this situation, the square root is your first problem. So to get rid of it, you're going to square both sides here. And then obviously you squaring both sides, you're going to have this cancel that. X plus 7. Here you're going to have x squared minus 10x plus 25. If you multiply out your brackets, you see. Because this is just x minus 5, x minus 5. So it's x times x squared, then x times negative 5 times x, negative 5 times negative 5. So this being said, you need to be careful, you see. So everything on one side, right? You can have here x squared, negative 10 minus 1, so just like negative 11. 25 minus 7, isn't that like 18? 25 minus 7, my guy. Calculator, help us out. Yes, it's positive 18. Fortunately, factors of 18 that give an 11. It's 9 and 2, so that one is not bad. X and x, 9 and 2. To get a negative here, you have to say minus and a minus. So a negative and a negative here gives you the plus 18 if you multiply them. So it's all good. Here you're going to have x minus 9 is equal to 0. The other one, x minus 2 is equal to 0. X is equal to 2. X is equal to 9. Okay, it's all good. It's good. The thing is, anytime you have stuff under a square root, always test out your answers, because usually one of them doesn't work. And this is something you always hear me say. So if you try out, let's try to 9. 9 plus 7, that's going to be 16. Square root of 16 is a 4. 4 plus 3, 4 plus 6 is a 10. And 9 here plus 1 is also a 10. So 9 balances out. The 2, you have 2 plus 7, which is 9. Square root of 9 is a 3. 3 plus 6 is a 9. If you put what you may call a 2 here, it's going to be 2 plus 1, which is a 3. The 3 does not balance the other left side here. So the 2 does not work. So you have to disregard it. You always have to check your answers, especially when you're working with square root symbols. D says, if the first 3 terms of a geometric series are these values here, then what is the value of n if Sn is equal to this? So it's a geometric series. So obviously we know Sn is equal to a Rn minus 1, R minus 1. So the idea is the first term we already know it's a 2. The number of terms we're adding up, we don't know. We're adding them all up to 177,146. And then what we do know is this is geometric, so it has a common ratio, and that common ratio seems to be 3. Because from here to there, 6 divided by that is a 3. This divided by this is also a 3. So here our value of A is a 2. R is a 3. 3 minus 1. Sn is 177,146. And then here you have a 2 at the bottom, right? And then 177,146. To get rid of the 2 down there, which you do want to, because it's solving for x, you're going to multiply. No. The 2's here cancel out, fortunately. And then here, you can take the 1 to the other side. It's going to be adding. So 177,147 now. So obviously here you're going to use logs to make n the subject of the formula. You make n the subject of the formula, you say log. The base of the exponent becomes the base of the log. Whatever this value is, you're going to write it over here. And then all this, you're going to put it in your calculator. So in our beloved calculator, this is coming out as 11. That's the way we like it. We move on now to question number 2. Question number 2 says we need to work this out using first principles. Or rather, it says using first principles, find the first derivative if f prime, if f is equal to x squared minus 5x. And then it says here, so it's a 5-mark question. So let us just dive into it. So anytime you need to work out something using first principles, right, you need to keep in mind that f prime, the formula, is equal to lim h goes to 0, fx plus h minus f of x, the whole thing over h. So the big idea here is you need to keep in mind that with fx plus h, right, fx plus h, this is going to be equal to x plus h squared, and then this is going to be equal to 5x plus h. So you need to expand whatever this is. This is like x squared plus 2xh plus h squared minus 5x minus 5h. So that's what's going to go over here. Where it says negative f of x, you're going to put negative x squared and positive 5x. So let us do that. Let's take this thing here, copy, paste it over here. And then here we have minus x squared and then plus 5x, the whole thing over h. So whatever f of x is, these will need to have something canceling them. If they're not all cancelled completely, you did something wrong. So here you have 2x. No, let's not forget the whole lim stuff. Otherwise, yeah, gonna get penalized for nothing. So let's just add the whole lim stuff here in the front because we need it. Lim h goes to 0. Lim h goes to 0. And then here you have 2xh plus h squared minus 5h over h. Here, you're going to need to take out h as a common factor. So this is like lim h goes to 0. Here, you're going to take out h. So this is like h 2x plus h minus 5, the whole thing here. This cancels that. You have lim h goes to 0, 2x plus h, right? Minus 5. And then at this point in time, you can throw in your h as 0. And then you have your f prime here. F prime is equal to 2x, 0 there, right? And you have minus 5. Which makes sense because if you were to differentiate this without a calculator, without the formula, you'd say 2 times the value in front, you have 2x, remove 1 from the exponent, and then minus 5. So this is what you would have if you had just used normal differentiation. So yeah, you can verify that your answer is correct. B here says the following. You want to find G prime. You want to differentiate, right? It's a 4-mark question. Differentiating this expression, you can see that what you do is anything under a square root symbol, right? There's a value here and there's a value there. The value outside, you always have to put it under the value inside there. So n over a is what you have. This is something you can differentiate, which is what you want to do before you differentiate. You always want to write it in a format where you have a coefficient, a base, and an exponent. So here, the 3 is going to go all under the 1 there. So it's going to be x with 1 over 3. Now, anything where you see that it's a fraction, what happens is you can take this value upwards and the exponent has to become a negative. Now you can differentiate. So differentiating this, you can have 1/3. If you remove 1 from there, you're going to have like a negative 2 over 3. And then here, negative 1 times 6 is like negative 6. Negative 1 minus 1 is like negative 2. And then this is what you're going to have as your answer. Nothing crazy there. C says if h is equal to this, if this equation, right, is a tangent to f, find the value of p. So remember, whenever we go through questions where they're asking for a tangent to a curve, we always say a tangent and a curve, they share two things. They share a coordinate and they share a gradient. So a coordinate is an x and a y value. A gradient, we also have an x value and a gradient. So this is like f prime. This is what these coordinates share, or this is what a tangent and a curve share. Their link is the x value, the specific x value where they meet. If you throw that into the gradient equation, it will tell you the gradient at the point of intersection. If you throw that into the coordinate equation, it will tell you the y value at the point of intersection. You see? So be careful of that. So if you're going to work out p, it's quite simple because here our gradient is minus 1. So what we can do is p is p seems like it is the y-intercept of our tangent. So if you want to get the y-intercept of the tangent, you want to get a coordinate that the tangent passes through, because a tangent is just a straight line graph. The equation of a straight line graph, when you're working it out, remember you're able to say y minus y1 is equal to m and then x minus x1. Here we already have m, it's negative 1. So all we need is a coordinate that the graph passes through. For us to find a coordinate that the graph passes through, we're going to use the gradient that we have, which is minus 1. This gradient of minus 1, we need a gradient equation to use it. Our gradient equation is the first derivative of f. The first derivative of f, we know that it is the gradient equation. So since it's the gradient equation, where gradient is, we're going to throw -1 there for us to find what is the x value at that particular gradient. So here the 3 goes over, it becomes a -4. And then what else do we have? We're gonna have the -4. Is it a -4? Yeah, -4. 2x, divide both sides by 2. You're gonna have the x is equal to -2. So since you now know that they meet where the x value is a -2, what you can do is you're gonna put a -2 in your equation of f. You put a -2 in your equation of f. Let's see what you're getting there. Right, you're gonna get your -2 squared plus 3 and -2 plus 4. And then -2 squared is like 4, right? So this is like -4, -6 plus 4. And then negative and the negative, these two cancel out, you have a -6. So this is a coordinate where the graphs meet, the curve and the tangent. So now you can now throw that in there. You see, y minus y1. y1 is like a -6. And then here you have x minus x1. x1 is -2. You see. So you have y plus 6 here, x plus 2 here. Here you have -x, -2. Then you have -6. This is like -8. Therefore, P is -8. There you go. So that's all nice and that's all dandy. Wait, what did you say 8P was here? -8. But no, P has to be... Oh, no. Come on, bro. What happened here? Negative that. -2. Oh, I made a mistake here. Yeah. This is supposed to be like a negative, then this is a plus. And then if this is a plus, it means this is a plus, this is a plus, this is a plus. It means that this comes out as a plus, this comes out as a plus, this comes out as a plus, this comes out as a plus. Because this would be a plus, meaning that this would be a minus. Yeah, damage control, eh? If this is a minus, you're gonna have here this times this is a plus, and then this, sure, doggo, this is what? This is a plus 6 now. So this would come out as a plus. This come out as a plus. Sure. Tick. No, this would come out as a minus. Right, now when you move it over, it becomes a plus. Yeah, P is 8. Question number 3, we have a functions question. It says here, the graph of f, right? It is an exponential graph. It has been drawn on the set of x's below. So they've said here, write down the domain. The domain just is a way of them asking which x values will this graph have. Are there any restrictions? As of this recording, the all access pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the all access pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. as a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen. That will stop this graph from having specific x values, and there are none. So when this graph is going up, it will stretch all the way to positive infinity there. Here it will stretch all the way to negative infinity there. So the domain, there are no restrictions. X is an element of R. That's how you're gonna write this one out. Second question here says, write down the range of f. So the range is now the y values. This is asking you which y values does the graph go to. Now this graph goes all the way upwards to infinity without any restrictions, and it goes all the way down until -2, like that, you see. So it starts from -2 going upwards. Those are the only y values that it has. So the y values have to be bigger than -2. And then say write down the equation of the graph that is a reflection of f in the x-axis. So a reflection in the x-axis, it means that the y values that are positive, they become negative. The y values that are negative, they become positive. Visually, a reflection about the x-axis, I mean, the whole thing is just gonna flip over. So where it's going up there, it's gonna go down instead. Where it's going down here, it's gonna be going up instead. You see, like that. That's a reflection in the x-axis. That's the visual appearance. But the equation of it, you're just going to multiply whatever equation you have with the -1. So this here is your equation of your new graph. So here it's going to be -3x² plus 2. And then that's your equation, you see, because look, this is a -2, right? The asymptote is going to be at +2 instead. Moving on, let's keep it moving. This question paper looks quite friendly. Yeah, determine the values of x for which the y values are bigger or equal to 0. That's what this question is asking. They're asking us where the y values of this graph bigger or equal to 0. They are bigger or equal to 0 over here. You see? And it's starting from whatever this x value is. So we need to find the x-intercept of the graph, you see? So finding the x-intercept of the graph, we have to just make y as 0. So we have here 0, right? It's got to 3 that minus 2. 2 goes over. We just need to make use of logs to isolate x. You see, x is isolated. You have logs. The base of the exponent becomes the base of the log. This value here is just that value on its own. And then you have, let's see, calculator. What does the calculator give us now? The calculator gives us 0.63. That's the way we like it. Well, getting the x-intercept is not enough, you see, because the question is asking us where the y value is bigger than 0. The y values are bigger than 0, starting from this x value going to positive infinity. So we're going to have to say here x is bigger or equal to 0.63. The reason we're saying bigger or equal to is because this is also there, you see. Let's keep it moving. B here says, what does B say now? It says on the same set of x's above, sketch the equation of g where g is this equation. This is not a difficult question to sketch because firstly, your asymptote is a +4. Is it a +4? Yeah. So somewhere there you're gonna have an asymptote. This graph, as your x values are increasing, right? You have to remember that the negative is separate from this. You see, so whatever you're gonna be doing, you just need to keep in mind that this graph is actually going to be going downwards, because as your x values, if you start, let's say x is a 0. If x is a 0, this is going to be anything to the power of 0 is a 1. So -1 plus 4 is a 3. So this is where 3 will be. This is where 4 will be. Now, if you think of x values to the left, let's say -1, -2, going on and on. This is just going to be a fraction. So the values are going to be negative fractions. If you add a 4, they'll always be close to the 4 there. If x increases, right, this number, it will be getting bigger and bigger. But then if you multiply by negative, this number is going to get small. So that already tells you that your graph is just going down like that. You see? So they said you should, if you're going to sketch this, you may be thinking, do I need to write out the x-intercept? You don't have to. I mean, like, you could if you want. I mean, just for the vibes, to show that you're competent. So let's actually just do it. Let's make y as 0, -2 to the power of x plus 4. Let's just take this over. It becomes a plus. Obviously, this is going to be 2 to the power of 2. So this is just a positive 2. There we go. You can even label it g of x. You could have also just used the table method in your calculator to see how the y values are behaving. It's a 3-mark question. So let's keep it moving, yo. Let us keep it moving. So let's see here. Question number 2 says, determine the equation of the resulting graph if g is shifted 3 units vertically up. So I mean, like, if the graph of g is moved 3 units vertically upwards, is what you're gonna have. The equation of g, you're gonna add 3 to it. If you add 3 to it, it means you have -2x plus 4, right? The whole thing. You're gonna add 3. So here you can have -2x plus 7. That's gonna be the new equation of your graph.
So this question says, show on your graph where you would read off this solution. So this is one of those, I don't know if I can call it like a trick question, but questions like these, right, you always want to make use of some of the information that, or some of the graphs that they would have been talking about within that question. So if you look at what we have within this question, right, we have the equation 3 to the power of x minus 2. Another equation that we have is the -2 to the power of x plus 4. So those two equations, if you look at them nicely, right, f of x, let's see here, f of x, right, is equal to what we say it was. Well, what is f of x again? f of x is equal to 3 to the power of x minus 2, right? And then the other one, which is the g of x, is equal to -2 to the power of x. I think it's plus 4. Yeah. So with these two equations, you have to keep in mind that when this expression is laid out, you want to think outside the box, but not too far from the box, because these are the kinds of questions where if you're gonna read off this solution, right, from your sketch, remember our sketch has this graph there, and it also has our white graph over there. So one way or the other, we, for example, if you want to visualize it, right, the graph that we just drew now, the one down there, see what it's going to look like here. Let's see what it's going to look like, because what you may call, if we were to draw on the same set of axes, we have 4 there, and it's going to be going down, right? So you're going to have your asymptote somewhere here, and then it is going to be going down. So we said it starts at like 2 and it starts at like 3. It's going to look something like this. Zoop. So with that thought in mind, right, you want to think to yourself, okay, fine, what happens if we equate these two equations? Do we end up with something like this? Which we probably will, you know, because these are the kinds of questions that end up some way, somehow like that. So if you say where is f of x equal to g of x, you would have here 3 to the power of x minus 2, and the -2 to the power of x plus 4. Fortunately, if you put everything on one side and the numbers on the other side. You put the ones that have an exponent of x on one side, you're going to have this. The 2 on the other side, you have 4 plus 2, which is a 6. So clearly, if you're going to get a solution for this equation, which is what they're asking, if you're going to read it off the graph, right, you have to just read where the graphs meet each other. So it says show on your graph where you would read off the solution. So on your graph, you would read off that solution at this point here, you see? And our question there is question 3. Question it's like B3, you see? So this is B3. There we go. That's where you would read off your solution. So obviously we read off our solutions where the graphs intersect. You see? Where the graphs intersect. There we go. So let's say here intersect. Okay, moving on to question number 4. 4 says the following. It says in the diagram below, f of x is equal to this equation, g of x is equal to this equation. You have the asymptote where x is a 2. That's the asymptote for f. Then it says y passes through c, which is a point that the other graph has as a coordinate. Okay, wait, you have the graph, you have the equation of f, it's the hyperbola, right? The equation of g is the log graph. Okay, that's fine. And then it says here y is equal to 1, passes through c. So already you want to know that they're trying to tell us that the y value there is a 1. We may not know the x value, but we know the y value is a 1. We can easily find the x value by just throwing it into the equation here, throwing a y value of 1. So it says here c is an asymptote of f. Okay, so we might as well, we know exactly where we're going to get our information. Because here they're asking if h of x is equal to this equation is an axis of symmetry of f, then determine the value of t. So all hyperbolas have two axes of symmetries. There's a positive axis of symmetry, and then there's also like a negative axis of symmetry. So the positive axis of symmetry is what they're referring to here, you see, because a hyperbola, it'll look something like this and like this, right? So one axis of symmetry will be like this, a positive one, another will be like that, a negative one. So they are talking about the positive axis of symmetry. So the positive axis of symmetry, let's just do this here. They want us to get the equation of this line here. So all axes of symmetries, right? They always pass through the point where your asymptotes meet. So funny enough, we can see, oh, the x value is a 2 because of our sketch. They're telling us the x value is a 2. So we don't have to, oh, they even told us there. Oops. So that's fine. Let's see. Here they now say we should get the equation of t if the axis of symmetry is this red one. It's the one with the positive gradient because the gradient will always be a 1 or a negative 1. So we need a coordinate that the graph passes through to get t. So we have that, which is just 1 and 2, right? Or 2, x is 2, y is 1. So you can just throw that into the equation, see? And then plus t. If this moves over to the left, we're going to have here 1 minus 2, which is minus 1. That's your value of t, which is the y-intercept, right? So this is minus 1. Let's see here. Moving on, calculate the coordinates of c. The coordinates of c, you see it's just marks given away. Oh, no, 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 no. That's not 2 and 1. This is 2 and 1. Hey, excuse me. One moment. Yeah, we still don't have the, what you may call this y value is a 1. X value, we don't know. So let's put that in the log graph, right? G with 3 and x there. Let's see, g of x is equal to log 3 with x here. Our y value is a 1. if you're gonna solve for x here, right? Remember, wherever x is, that's like the base of the log. So the base of the log is this value here. This is whatever is on the other side. So if you want to reshuffle this you make it a base, this you make it an exponent. You see, this you leave it on its own. So x to the power of 1, and then the 3 you leave it on its own. Clearly, if anything to the power of 1, that gives a 3. X has to be a 3. You see, because this is to the power of 1. So these exponents already match, so the bases have to match also. So x has a 3, which makes sense. I mean, like, given with what the sketch looks like. Moving on, they want us to get the length of AB. If you're going to get the length of AB, you're obviously going to need to find the x-intercept there of the one graph, the x-intercept there of the other graph. So getting the x-intercept of each of these graphs, not a big deal. The only thing is, with the equation of f, right, we have to get the full equation first for us to get the x-intercept. Fortunately, we know what P and Q is. P is going to be a 2 over here, because it's minus 2 over there, and then in the equation it's plus 2. For Q, you take it as it is. See, if there's a plus 1 there, as we told, this is also going to be a 1 here. So let's write down the equation. You see, on top there it's like a 5, so it's 5 and then x minus and then this is plus 1. We need to find the x-intercept, so you have to make y a 0. Y is a 0, minus 2 plus 1, minus 1. This is over 1. Then you have to cross multiply. 1 times 5 is a 5, negative 1 times this, and then you have negative x plus 2, 5 there. The x goes to the other side, you have 2 minus 5, which is like a minus 3. It makes sense, definitely. So for the log graph, the x-intercept, we have to make y a 0, right? So for the log graph, which is g of x is equal to log 3 with the x there, what we do know is that this y value is a 0. And then, remember we said if you want to reshuffle this thing, this is the base, right? This is the exponent. This value go on its own. Anything to the power of 0 is a 1, so x is a 1. Visually, that makes sense, because I mean, like, if this is 0, and this is 1, this is 2, yeah, that makes all the sense in the world. So distance of AB is going to be 4 units, you see. So here, therefore, AB is equal to 3 plus 1, which is 4. Because when you look at distance on a Cartesian plane, you don't worry about whether something is a minus or a negative. I mean, you don't have to worry about a minus, because distance is always a positive value. So the units from the origin here, it's 3. Units from the origin there is 1. So the distance is 4. For 2 marks, they want us to get the equation of the inverse of the graph of G. So that's what this means. We know that. Getting the inverse, we already know the game. X becomes Y, Y becomes X. So in that situation, we obviously need to, we know that originally this is what it looks like, right? Like, without any doubt, this is what it looks like originally. So in this situation, you're going to swap the X and the Y. See? So X becomes Y, Y becomes X. So with that being said, I need to isolate Y. To do that, we say this we consider it a base, this we consider it an exponent. There's your equation. You can maybe write Y first. There you go. That's your inverse for 2 marks. E says for which values of x is this equation smaller than 0. So for you to answer that kind of equation, you obviously need your sketch, and you need to be careful of how you're going to answer these kinds of questions. But you just need your sketch. If you know how to read your sketch, you'll be good to go. It's really not that difficult when you know how to read your sketch. So let us read our sketch properly. Let's read our sketch properly. So this is just asking, if you take the y values of f, right, you multiply them with the y values of g, where will you have numbers that are smaller than 0? So the way you answer these questions, you have to be methodical. You cannot just do it randomly. So the method to answer these questions, you have to look and see, we're taking one expression or one number multiplied by another number. The only way this can be smaller than 0 is if the first number is a plus while the other one is a minus, or the first number has to be a minus while the other one is a plus. So those are the only scenarios where our value here is going to be smaller than 0. We have to look for where the y value is here plus, while these ones are negative, y value is here minus, while these ones are plus. So to do that, you can just go to your sketch, right? And just like use color. You can use whatever you can to just see where do these graphs have positive y values and negative y values and all that. So if you start with the graph of G, this is where it has negative x. I mean, this is where it has negative y values, right? So, and then up here, this is where it has positive y values. Fine. For the other graph of G, F rather, this is where it has positive y values. And then only here, going upwards, is where it also has positive y values, right? Now, where it has negative y values, it's over here, see, like that. So all you need now is you have to scan your sketch from the left side going to the right side. And you have to look for places where your graph has positive y values while the other one has negative, and then vice versa. So this doesn't count because they both have positive y values here, all the way here. All these are positive y values, positive y values, positive y values, all the way until your asymptote here of 2. Because if you look at where your asymptote is, right, the x value here is a 2. If you look nicely between 2 and 1 here, right, between 2 and 1 here, let's put b here, right, between 2 and 1, there's 2 here, there's 1 here, x value of 1, x value of 2. Between that space, you see here, these are negative y values, these are positive y values. So that's a space that qualifies. If you could moving to the left, these both have negative y values, so it doesn't count until all the way to infinity to the left. So there's only one space here where you have positive y values and negative y values. So
as of this recording, the all access pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the all access pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
we can see here our x values are they're bigger than 1 or they're smaller than 2. That's one way to answer the question. Another way you could have just said is x is element of positive 1 up until positive 2. Another way you could have written it out, you could have just said x is bigger than 1 or x is smaller than 2. These are all three ways of writing the same thing. So you can just choose which way you want to write it out. You see, three ways of writing with two t's. The same thing. Yeah, I always ask myself that question quite often. Writing with two t's or with one t? Because writing with two t's like this, that seems weird. But who knows? Maybe that's the correct one. Yo, thank goodness it's not English. Let's move on to question 5. Question number 5. So question number 5 looks as follows. It's a 4-mark question. It says refer to the pattern below, right? It looks like a quadratic pattern, but let's see. Or maybe, yeah, it looks quadratic. But let's just find out actually, because there's no need to guess. It's going all the way to 949. This is plus 5. This is plus 9. Yeah. And then this is plus yola h. Let's see. My mental math is just in my calculators. Yeah, net 1 minus 8 is what? You may be wondering, why am I not just using calculator? Because it's 4. This is plus 13. Yeah, of course, because there's 4 extra. Yeah, this is a quadratic number pattern because there is a second common difference. You see? 2 and 2. No, 4, bro. But anyways, it says determine Tn. If you're going to determine Tn, you obviously have to do all we have just done now. You have to see the sequence of first differences. You have to see the common difference. So that you start from the bottom and you say, this is equal to 2a. This 5 here is equal to 3a plus b. This is equal to a plus b plus c. So all that being done, you have 2a is equal to 4, right? 2a is equal to 4. You're going to have the divide by 2 on both sides. A is a 2. Then you're going to put a 2 here. And then you're going to have the 6 plus b is equal to 5. 5 minus 6, right, is negative 1. And then up here, you're going to say a plus b plus c, right? So it's like a is a 2, b is a negative 1, c is like that. Fine. So this is like 2 minus 1, right? And then you have the 2 minus 1 is 1. 4 minus 1 is 3. So that being said, right, you're gonna say you therefore remember your equation of a quadratic number pattern, it's gonna have this format. You see, so your a value is 2, and then your b value is minus 1, your c value is plus 3. There you go. That's the way we like it. So that's all fine. Nothing crazy, nothing major. We can actually just move on. So let's keep moving forward. Determine the number of terms in the series. So if we're going to determine, before we move on, let's just test our sequence. You see, if you put a 3 in here, you have 3 squared is 9 times 2 is 18. 18 minus 3, and then plus the 3, still becomes 18. Yeah. If you're going to determine the number of terms in the sequence or in the series, right? The thing is, this is our general term, right? So this being our general term, what we already know is that we can put in 949 where Tn is and find out where 949 is in our sequence. You see, so 949, and then 2 to the power of 2 with n squared minus n plus 3. Let's solve for n. 2n squared minus n plus 3, and then minus 949. So the idea now is 2n squared minus n. 3 minus this, right? You're obviously going to have minus 946. Yeah. And obviously this is the kind of a question where you're going to have to use the quadratic formula. Let's see here, b squared minus 4ac, the whole thing over 2a. Let's put everything in our calculator. No. Before we put in the calculator, obviously, we have to put everything into the formula. So minus 1 here, squared plus, no. It's minus, bro, minus 4. A is a 2, C is a negative. Yeah, so usually when our value of C is a negative, right, it usually means that our value of B is a small number, which is fine. So negative 4946 here, whole thing over 2a. So here our value of n, let's just get that from our calculator. So the answer to this question, if you check in your calculator, is going to give you n is 22, or n is equal to negative 43 over 2. So this we have to automatically disregard, because you cannot have a term that's in position negative something. So we can say here, therefore, there are 22 terms, you see. Therefore, there are 22 terms. There we go. This is represent the series using sigma notation. So sigma notation is simple. You need to find out where you are adding up from. So you need to find out where your starting point is, where your end point is, and your general term. So fortunately here, we have the general term. We have where we're starting. We're clearly starting from the first position until position 22. So you're going to say here, ending at 22, starting where n is a 1, your general term is 2n squared minus n, and then minus 949. No. Bro, come on. Why are you blundering like that? It's plus 3, bro. Come on now. Plus 3. There you go. That's your sequence in general. That's your sequence in sigma notation. You see. So let's keep things moving. Question number 6. Question number 6. Oh, financial maths. Okay, so with this financial maths question, let's see what we have to do. It says here the details of an investment opportunity with a company called Phantom Investment House are given below. Monthly payments of 5,000 need to be made at the end of each month. The interest rate offered is 15% per annum compounded monthly. Then it says that you decide to invest with Phantom Investment House with the terms given above. What would the value of the investment be after 3 years? It's a straightforward future value annuities formula question. So your future value annuities formula, you can get that from your formula sheet so that you don't like write it down incorrectly or anything like that. So since we're trying to figure out how much the money is worth after 3 years with these terms, X is our monthly installments, which is 5,000. Interest, they say it's 15% per annum compounded monthly. So you have to divide the 15 by 12. N is 3, right? But because it's compounded monthly, you have to times by 12, which is 36. And then now we can just solve for F by putting everything into the equation first, and then afterwards we're obviously going to just put it into our calculator. So on my side, I do write down the percentage symbol in the calculator, and then I just put over 12 there. So just be careful of that, you see. 15% over 12. Let's see what this gives us in the calculator. So everything in the calculator here, it is giving us 225,577.53. That's a 4 simple mark question. The simple 4 mark question. Ooh, 5 marks. Yeah. It says, what is the minimum number of months required for the investment to reach a value greater than 2,500,000? That's also simple because you have to work out a value of n, right? in your F formula. So in your F formula, we're obviously going to need to isolate n first. Isolating n is just algebra. So I'm going to multiply by I on both sides first. Fi is equal to x 1 plus I of n minus 1, right? We can divide both sides by x here. Divide by x, divide by x. Fi over x, we have here 1 plus I to the power of n minus 1. So all this being done now, the negative 1 can go over to the other side. That's Fi over x plus 1. This is equal to 1 plus I to the power of n. So since we need n, or want to isolate n rather, we can do that. Remember, if you want to isolate an exponent, you isolate it, and then this is the base of whatever log you're going to have. You're going to have log here, the base of the exponent you've isolated, and then this value on the other side is still just there. So it's always good for you to know how to isolate n because it makes it easier for you for these kinds of questions. They're asking the minimum number of months, right, for your investment to be greater than 2,500,000. So you can just make F 2,500,000. Your interest, you know, your monthly installment, you know, and then you can just find out what month is required. So let's see here, log, then, well, come on, bro. Log here, 1 plus 15% over 12, and then here 2,500,000, and then 15% over 12, the whole thing over 5,000. There is n here. So all this being done, right? You obviously want to keep in mind that the only thing that can throw you off is your calculator. So you just need to make sure that you put your calculator stuff properly. So everything in the calculator here is looking all nice and neat. Let's see here. Yeah, so judging from the value in our calculator, right, we can clearly see that n here is equal to 160 months, and we obviously need to keep in mind that that's definitely going to be the minimum number of months it's going to take for you to reach that value. So I say here, therefore, 160 months minimum. So obviously in your calculator, if things come out as like 159 point something close to 9 or 999 or whatever, obviously you're gonna round it off to like 160. So let's keep things moving. Question number 7 for 4 marks. It says the following. Question number 7 says you approach a bank for a home loan to the value of 850,000. This needs to be paid off monthly over a period of 20 years. Wow. The interest rate offered on the home loan is 9% per annum compounded monthly. And then it says here, what are the minimum monthly payments required to pay off the loan over the 20-year period? So we need to, it's a monthly installment when you're paying off a loan. So this is the formula you need to know, the present value annuities formula. All this information is clearly laid out on the functions and graphs course on our website. So on our website, as of this recording, there is currently a sale, which is more like the end year sale. I mean, like as of this recording, the year is coming to an end. So you do want to keep in mind that when the year does come to an end, the courses will go on sale. I mean, as of this specific recording, the package that gives you access to everything is currently going for just 99 Rand. And the courses are definitely IAP and kept compliant. So you see here, all access pass, once off, you have access to like 17 products. And then for just that single fee, you can have access for a total of 60 days. You see, it says here, this bundle gives you access to everything on the website for a single price of 99 Rand. It is currently on sale. Once a purchase is made, you have access for 60 days. So This boundary includes things like Euclidean geometry, functions and graphs, applications of calculus, trigonometry, analytical geometry, sequences and series. It's practically your entire syllabus, right? Algebra and the NBT courses included, financial maths, probability, statistics, everything that you basically will need for your grade 12 maths is on our course platform. You'll be able to get those marks. You can also grab a study guide if you want to have extra information from whatever it is that you'll be studying. Moving on with what we're talking about here. So if you're going to isolate x in the present value annuities formula, that one is actually quite simple, simpler than isolating n. So you're going to multiply by I on both sides. You can have pi here, 1 minus 1 plus I to the power of negative n. So from here, isolating x, you can see you just have to divide by the big bracket. And then here also divide by the big bracket. 1 minus 1 plus I to the power of negative n. So all this here, let's see, this cancels this. You're going to have x is equal to p multiplied by I. 1 minus 1 plus I to the power of negative n. There you go. So solving for x here, right, it's not going to be a hassle. You just have to make sure you put your values properly in the formula. So in our case here, the money borrowed, right, is the entire 850,000. That's P. Interest, they told us it's 9%. So 9% compounded monthly, remember? And they said it's over 20 years. It's 20 times 12, which is like 240. Those are our values that we're going to throw into our formula. So let's just throw them into the formula. So 850,000. This is an IEB paper. Now, if you're a CAP student or an IEB student, whichever one, the one thing I do want to let you know is that these papers, right, the syllabus, really nothing much is different. Forget nothing much. Everything here is exactly the same as how you would get it in a CAPS paper in terms of the level of intensity even. To be honest with you, so far with everything that I've done, it looks a bit even simpler than a CAPS paper. So this whole issue of saying CAPS is easier, IB is harder, it varies. Some papers are harder, some papers are easier. But obviously, in general, you do get the harder questions in IB. Like let's say if they ask hard questions, they're gonna ask more hard questions in an IB paper, or the level of hardness is gonna be higher for IB. But to say that two syllabuses, one is harder than the other, nope. IEB, they just sometimes, they're gonna ask hard questions, they'll make them hard, but then it's not like the whole paper is like crazy questions. These are all quite normal. So if you're a CAP student, I hope you're seeing that there's really nothing much to be thinking to yourself when it comes to this kind of a top the syllabus. It's all good. It's all good. Everything's all the same. So X in the calculator, 7,647.67. Let's move on to the next question, which is B, right, out of 5. Okay. So this 5-mark question says, if the monthly payment is charged at 9 Rand per month, is changed to 9,000 per month, then what will the balance outstanding on the loan be at the end of the 12 years? This is directly after the payments is made at the end of the 12 years. So this kind of a question, right? The one way to work it out, right, is you have to use your outstanding balance formula. Now, the outstanding balance formula, you have to be careful. You see, because when you use the outstanding balance formula, it's pretty straightforward, because it makes use of two separate formulas. You see, it uses the future value annuities formula, and it also uses the compound interest formula. So that's how you get the balance on a loan after a specific number of months. So your balance is always A minus F. A being the compound interest formula, so it's P 1 plus I to the power of N. F is the future value annuities formula, so you're going to have your X 1 plus I to the power of n minus 1, the whole thing over I. And then P. P is your loan, your original loan. Interest, we said it's 9% per annum compounded monthly over 12 years. 12 times 12 is like 144. Monthly installment is 9,000. Let's move everything to the left here so we have like more space for what we're doing. So 1 plus interest, and then 144 months have passed, the whole thing over 9% over 12. So let's put all this in the calculator. You just have to be careful. You can either put the first part here for A, get an answer, second part for F, get an answer, but meh, can I just throw everything to the calculator? So let's do that. Everything nicely thrown into the calculator. We're getting here 173,507.13. So it looks like if it does have a higher monthly installment, this loan seems like it's getting paid off quite fast. But let's move on now. We have gotten our answer. We can move on to question number 8. So if you have any questions on anything that we're doing, please just hit me up on IG. And just search LE_EVY. There's an underscore here, but the line is like covering it. Oops. So good, so good. Let's move on. Question 8 says the first two terms of an arithmetic sequence is this value and this value. They are terms of an arithmetic sequence. Then they said here, if the common difference of the sequence is a 1, what is the value of x? So this question, very, very direct actually, because you don't want to overthink it. If they say this is the first term, right? And then they told you this is the second term. And they told you it's an arithmetic sequence. It just means that this minus this gives you your common difference. But then they told you your common difference is a 1. You see, so what you know is log 3x minus log with a 3 here and x minus 5. This is a 1. You cannot solve for x, you just need to solve this equation. Now, this is where your log laws come into play. You need to know your log laws, because if you don't know your log laws, then yeah, you are a bit in trouble, because so the way everything looks, right, it looks as though, you see here, there's like log with a 3, log with a 3. So what we're looking at here, this is clearly something that we can use the division rule, you see, because the division rule literally just needs us to have the log with the same base, and then you'll be able to take this value divided by this one. So here we can just say x over x minus 5 equal to 1. This one we can put it over 1 also. Woo, somebody's hungry. So let's cross multiply. 1 times x here is x. 1 times the bracket down there. Here's what you have. X can go over. Oh, come on. No, man. No, 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 no. Seems like it's bombing out, which it is not supposed to do, which is like, come on, man. Come on. Let's see what we can do here. So our log laws quotient rule. Oh, no, 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 bro. Come on. The quotient rule needs us to still have the log thing here. There will be log with 3 here. Yeah, that was the problem. Yeah, let me just move this a bit lower. Yeah, it's supposed to look like this. So all this being said, right, from here now, the 1, this is where you need to know your log laws. Because if you have a 1 and you're dealing with logs, right, and your expression is equal to 1, you can write this as log, whatever the base is, you put that there, and then you put, as long as these numbers are identical, you're going to get a 1. And then here you see a log with a 3, x over x minus 5. But then fun enough, you can see now all this means is this part that's inside here is equal to 3, you see. So you're going to have here 3, and then x over x minus 5. Now you can do that whole cross multiplying thing that we were about to do. So this times the 3, right, it's like 3x minus 5. 1 times x is like x. And then let's multiply inside here. 3 times x is 3x, 3 times negative 5 is negative 15. And then what else? The 3 goes 3x minus x, right, is 2, and then 15 there. So it looks like our value of x is gonna be 2 over 2 there, 15 over 2 is like 7.5. That's the value of x. So this is an answer for x. Yeah, definitely looks believable, because I mean, like, everything we did here, there's definitely nothing that was like out of place. So let's move on. B says a converging geometric series. So automatically, when they say converging, your value of r is between -1 and +1. So since we know that, we need to keep in mind that it says here a converging geometric series is such that the second term is -24 and the sum of the third and the fourth term is equal to -18. Determine the common ratio. It's a 5-mark question. 5-mark questions are really not that bad, because they just need you to read your question again while making notes, you see. So converging geometric series, second term is 24. So if it's geometric, remember your expression has, the first term is a, the second term is ar, the third term is going to be ar to the power of, this is to the power of 1, this is going to be to the power of 2, and then here ar to the power of 3, going on and on and on. So this is like t1, t2, t3, and t4, going onwards. And then it says here, so you want, they say t2 is 24, right? -24. So you have a here, ar is equal to -24. That's t2. And then they said, no, they said that such that the second term, which is 24, and the sum of the third term. So third term is ar squared, right? Which is what is -18. So they said the sum of these two terms, what you call, no, it says a converging geometric series is such that the second term is 24 and the sum of the third and fourth terms. So if you add term number 3, right, and you add term number 4, you get -18. They said determine the common ratio. So that's going to be easy, because we just need to work out a and r simultaneously. Equation 1 here, equation 2. We read that from the statement. So this is clearly something you need to know. It will always help you. That being said, here we can isolate. It looks like we can isolate a, so that we can throw a here and get r. So here, a is going to be -24 over r, and then we put that in here. So -24 over r, we're going to put that where a is, then this is r squared. No. Before you do that, it looks like you may want to maybe factorize first, which we can, right? We can take out a common factor here. ar squared is a common factor. You have here 1 plus r is equal to -18. So we might, since we're solving for r, right, let's isolate, well, we cannot isolate r the way it is. Yeah, but let's throw a now. Throwing a, we're gonna have here, or rather, let's maybe no, let's isolate a here also. So here we've isolated a, right, in the first equation. Let's isolate a also here by taking out a as a common factor. R squared plus r to the power of 3. Value of a is like -18 over r squared plus r to the power of 3 if you divide. So you can make the a's equal to each other, you see. Therefore, -24 over r is equal to -18 over r squared plus r to the power of 3. Here you don't want to get an LCD. Just cross multiply to get rid of fractions, since it's a fraction on one side of the equation and another fraction on the other side of the equation. So let's move on, right? So let's cross multiply. R times -18 is going to be like -18r. -24 times this is like -24r squared plus r to the power of 3. Solving for r here, it looks like we're going to end up with some, cubic expression, but let's see. -24r cubed here, -24r squared as a minus I just wrote it out so that the 3 comes first and the 2 afterwards. And then if the 18 comes over, it's going to become a plus 18r equal to 0. So let's take out r as a common factor. We can actually take out, let's see, I think 3r. No, is it 4r? No, 3. 3 is the biggest, no, 6 is the biggest number that can go into all of them. So 6r can be taken out. Let's actually, 6r, negative 6r, or let's just take 6r. No, negative 6r. Let's just say, come on, bro. Here you're going to be left with negative 4 r squared. Then here again, negative 4 r. Then here, if 6 is out, you're going to be left with the 3, r is gone, so there's nothing there. So here you're going to say, what you're going to say here now. So all this is being done. Wait a minute. The sum of the third and the fourth term. The sum of the third and the fourth term. Why am I seeming so? Anyways, no, everything looks fine so far. So let's just carry on. So here r, the 0 divided by 6. R cannot be a 0, you see. So this one we don't have to consider it. We just have to consider this one. We can just use our quadratic formula for that one, you see. R is equal to minus b plus minus b squared minus 4ac over 2a. So yeah, the quadratic formula is something that is very close to my heart. Because I used to not know how to factorize. So I overdosed on this formula. Like overdosed on it, bro. So I have never let it go, even after I knew how to factorize, because it got me through the bad times, So during the good times, I still remember it also. Negative 4 there, and then plus 3 here. Whole thing over 2 times a. So this you can just get in your calculator. Let's see what the calculator gives us. Okay, our calculator is giving us r as negative 3 over 2. The other one, r is a half. There we go. So if it's converging, it means that r has to be bigger than negative 1. So this cannot be a valid answer, you see. So here r is only equal to a half there. That's how that's why you see your theory is important, for you to then be able to cancel and all these things. Yeah, because you cannot just take all the answers. Let's move on. She said, you are the manager of a large sports stadium. A soccer tournament is held at your stadium, where one match is played each day for 12 consecutive days. Wow. The following rules and regulations have been given to you as the manager. At the first game, the maximum spectators is 25,000 for each subsequent game. So for each game that follows, the number of spectators can increase by a consistent number so that they can increase by a consistent number so that the last game has 58,000 spectators in the stadium. Assume the maximum number of spectators attends each match. Okay. Determine the increase in the number of spectators between any 2 consecutive days of the tournament. So, as of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website, where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card,
or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen.
Yeah, this is some kind of a sequence. Obviously, it starts at 25,000 spectators, right? And then the next day, you don't know, going on and on and on until the last day, which is 58,000 spectators. So the issue is, in this sequence, this is term number 1, right? Term number 2, you don't have going onwards. But you know the last term here is 58,000. So the other issue is you don't know what the common difference is. But you know the first term is 25,000. So you have two things missing. No. They say this has to be the 12th day. So you do know what this is. This position number 12. You're only missing the common difference. They say to determine the increase. So the increase is going to be the common difference. That's why this is just a 3-mark question, because it's an arithmetic sequence since your increase is subsequent. Subsequent just means that no. For every game, the increase has to be constant. So we have a constant difference. So here Tn a plus n minus 1d is the formula we're going to use to get the value of d. Because this is 58,000. Our first term is 25,000. Our value of n is 12. Our value of d is what we're looking for. So this is like 25,000 plus 11d. And then we need to move everything to the left. 58,000 minus 25,000 equals 11d. So all this being said, right? Let's see. 58,000 minus 25,000. What do we get there? That's like 25,000 plus 8,000, which is like 33,000. So divide both sides by 11 here. Let's see what we're going to get. D here. What is the value of D? 3,000 in the calculator. So that's fine. Value of D is 3,000. Let's keep things moving. Question 2 here says, if a spectator pays 25 Rand for a ticket each day, then what is the amount of income that can be generated from the ticket sales if all the rules and regulations were followed? So the fortunate thing is, if you look at it logically, the first day, 25,000 people, right? The second day, you add 3,000, that's like 28,000 people. And then you add another 3,000, that's like 31,000 people. Going onwards, right? Until you have 58,000 people. The good news is, on this first day, you have 25 Rand each. The next day, 25 Rand each. The next day, 25 Rand each. The fortunate thing is, if you were to add up all these people, right? Technically speaking, if you add up all the people, you can just multiply by 25 once and then get your answer. So to do that, we can just get the Sn, the sum of the first 12 terms in this sequence, right? Using our Sn formula, we can just get the sum of all those people and then we just multiply it by 12. It is just that simple. So let us do that. No, and then we have to multiply by 25, sorry. So here, our Sn formula, you're gonna have 2 plus 2a plus n minus 1d. Let's see here, you have to put a S12, right? S12, 12 over 2. Our a value is like 25,000. Our n value is, what is the value of n? 12. Our value of d is common difference, right? That's like 3,000. Wow. So fortunately, this entire number can go in the calculator. So let's do that. In the calculator, 498,000. Those are the total number of people that came, you see. They told us each of them paid 25 Rand. So here you're going to have 25 times 498,000. In our calculator, 12,450,000. Yeah, that's okay. Let's move on to question 9. Question 9 here says, a sports scientist is looking at ways to throw a heavy object further. The diagram below shows the two throws and models. No, the diagram below shows the two throws and models them on a parabola. Says the first throw starts at O, it reaches a maximum height of H. The second O, no, it reaches a maximum height of H and ends at M. So remember, this is a parabola. It means that H is in the middle of O and M. Don't forget that, because a parabola is symmetric or symmetrical. The second throw starts at O, highest it goes as A, furthest it goes as N. So the middle here is the middle of O and N. Okay, for 7 marks, if the second throw is 2 meters further than the first throw, then what are the coordinates of H? So if the second throw is 2 meters further right, asking for the coordinates of H. So this is what we can do. So firstly, well, let's read that again. If the second throw is 2 meters further than the first throw, then what are the coordinates of H? So you don't have to panic with this kind of a question. Just get as much information as you can on the sketch. So obviously this is where the question paper sort of like goes into like Super Saiyan mode or something. Because yeah, 7 mark questions, they're just a bit uncommon in caps, but that's just the difference really, in my opinion. But the level of thinking more or less the same. So here, what you can do first off is use variables. What you know is this is 0. Whatever the x value is here, you can label it x. Whatever the x value is in the middle here, you can label it half x because it's in the middle. So if this is like a 4, this is like half of that, which is a 2. They say this is 2 units further, so you can label this x plus 2. So the key thing is when you work with stuff in your maths, always try and use the same variable, and then you'll be good. So if this is x plus 2, it means that in the middle of n here, you have x plus 2 divided by 2. So you now have an expression for each x value. You have the expression for x value here, x value here, x value here, x value here. So we had chosen to make this x first because, I mean, we can, you see? And then here we just know it's half of that. And then after that, let's see, this is x, right? And then half of that. And then here, this is x plus 2, and then half of that. So let's see what we can now do. So all things considered, or all things said, let's now even look at the question again, because they're now, what did they ask us? They said if the second throw is 2 meters further than the first throw, then what are the coordinates of H? So since this is a parabola, what you can think of is the equation of a parabola to a certain extent. So an equation of a parabola, what we do know is the equation of a parabola looks something like this. Y is equal to ax squared plus bx plus c. So this factorized will always be a x minus x1, x minus x2. And then all that being said, right, what you have to consider is this is the x-intercept, the first one, this is the second x-intercept, this is your value of a. So this is our parabola. Our first x-intercept is a 0, right? Our other x-intercept is just x. So if you put that into your equation here, you'd have a, and then here you'd have x minus 0, and then x minus x, you see? So that's what this is. The only thing is our y value of h here. Let's see what the y value of h is. Whatever the y value of h is, right? We don't know what it is. But fortunately, we have a, so we can use that. Yeah, it looks like A is more useful. It looks like the other equation is more useful. If we can get the other equation and somehow get X, I think we'll have something to work with. So here, let's just leave this for now because it's really not helping much if we're thinking of working with H directly. So which is how you want to also think of your maths questions. When you work with something that has no information, it's not going to get you much. So try and use something that has information. So it looks as though if we can get information of the larger parabola, we'll get X eventually. And if you get X here, it's good because if you have X here, you have this X value, you have this X value also. You'll have the turning point, and then you can easily then get the equation. So let's do that. In the second equation, I mean, fortunately, things will stay the same, right? Where we have to say y is equal to what you call a, and then x minus x1, x minus x2. So the thing is, with our larger parabola, our x1 is a 0, our x2 is the x plus 2 here. You see? So let's throw those into our equation so far and see what comes out. Remember, we're trying to see if we can get its equation or more information. A stays a, x minus 0, x minus x plus 2, right? So remember, don't find yourself making the mistake of working this out algebraically, because I mean, like in our case here, let's actually make this, you know, a random variable so that we don't find ourselves making a dumb mistake. Let's just label this like Tn, and then we put n here and n here for the sake of not using the same variable multiple times. Otherwise, it's going to be a problem. So in our situation here, the Tn is just representing a coordinate, you see. So this is just coordinate. So fortunately, we have a coordinate that the graph passes through. It is the 4 and 2 here, x value 4, y value 2. So 4 equal to a, 2 minus 0, 2 should multiply the negative. That's like negative x, negative 2. 2 minus 0 is just 2, right? So this is like a times 2. 2 minus 2 is a 0, so you have minus x here. But then, yeah, that's what we are getting, you know? So we have two variables in this expression. So it's like 2, negative 2ax actually. Then you have a 4 here. We could isolate what? Well, that's kind of weird here. Let's just divide by negative 2 on both sides and see negative 2 here, ax. So we have an equation that is a and x. Let's see if there's anything that can get us more information. Oh, baga. Dude, we can easily get x because half x plus 2 over 2 is a 4. Because this is the x value. Yeah, this is what we can use to get x, you see. So that we eventually get a from what we're doing here. So yeah, no, all hope is still there. All hope is still there. So let's just carry on with what we're doing here. So here where x is, let's just solve it, you see. Times 2 times 2. There's a 8. X plus 2. 2 goes over. 8 minus 2 is a 6. So remember, for you to stay confident in your maths exams, don't take too long to start writing stuff out. Write what you know you have. So here you can throw x as 6 there. So negative 2a, x as 6. Then I have there 6a, negative 2. I don't even know why I'm carrying on doing all this, getting the equation of the larger. So larger, it doesn't seem like we need it actually, but let's just quickly finish it and just see what we can then do. So if we have the full equation of the larger one, I mean, all we actually needed was x. I feel like this was all unnecessary, to be honest. All we needed was actually x, to be honest. But let's just see what happens if we now have x. If we now have x, it means that this is just this is now a 6, right? This is half, which is like a 3. So you have 0 and 6, and then the middle, which is a 3. So the equation of your parabola, right? You can actually, yeah, that's what you can do. You can say y is equal to k, x minus x1, x minus x2. The thing is, we have the x1 is clearly a 0, the x2 is clearly a 6. And then to get k, we can sub in a coordinate that the graph passes through, but we don't have anything. So this format, if it seems like it's failing us, let's go to this format here. Y is equal to, let's just say k, no, hey, yeah, ne? ax squared plus bx plus c. Now the big idea here is we may want to use different variables like we said. So let's just see here t. Yo, bro, come on. I'm trying to not use the same variables twice and all that, but to be honest, all this here it looks like it was unnecessary because this is all getting the equation of the other graph, which we don't need. All we needed from the other graph was what we wrote here to get a value of x. So as long as we got our value of x here, well, okay, we might as well just use it to get what we want. So as long as we have x here, what we can do is the equation of our parabola, we can say y is equal to ax squared plus bx plus c. So we need a, b, and c. Fortunately, c we already have. It is what you may call, it's 0. Remember, the main question is asking us to get the coordinates of h, which is the coordinates of the turning point. So if you have the y-intercept is 0, so far you have y is equal to ax squared plus bx plus 0. Fortunately, you just need a and x, two variables. Now, the fortunate thing about h is the x value is equal to minus b over 2a. Now, what you already know about the x value of h is that it's half x, which is just a 3, as we have already seen here. Half of x is just a 3. And then we have here b, negative b over 2a. So we have an equation that has b and a. So let's maybe isolate b. Times 2a times 2a. This is like 6a. This is equal to negative b. Divide by negative, that's like negative 6a, which is a b here. So all this being done, right? We have b now. So obviously, we need another equation that is a and b. Fortunately, we need a coordinate that the graph passes through here to throw in. We can throw in one of the x. One of the x-intercepts, which is the 6 and 0. We can throw in that coordinate here. So y value is a 0, x value is a 6. Let's see here, b times 6, right? So this is like 6 squared, which is like 36. 6 times b is like 6b, that's a 0. Let's isolate b here. Minus 36a equal to 6b, divide by 6 on both sides. Our value of a is a negative 6a. Getting the same darn thing. Bugger. Oh well, so I guess we do know that we have something. We just have to find out what we can do to get the other set of equation. Yo, come on, man. I feel like I'm having a blown moment now. This is also a point that the graph of h also passes through. So the other parabola also has this coordinate. Like, wow. So that makes our life so much easier because we, instead of us throwing in 6 and 0 here, we can just throw in the 4 and the 2 also. And then we'll have another equation that is a and b. So the x value here, we said we can throw in, what other x value can we throw in now? We said 4 and 2, so let's see here. X value is a 4, y value is a 2, you see? We're throwing it into the equation of the parabola because the x value here is a 4, y value is a 2. Solving for x here, or solving for a and b, we have 16a plus 4b and the 2. Making b the subject of the formula, you have 2 minus 16a divided by 4 everywhere. So what we get, you have a quarter, 4 minus 4a equal to b. Make the b's equal to each other. You have a quarter minus 4a equal to negative 6a, right? Negative 6a plus this is going to give you a negative 2a. You see? And then here you have, yo. What is going on? It doesn't look like it wants to work out nicely. Now, this is a half, bro. Come on, man. A half, man. Come on, bro. I'm making dumb mistakes like this when we're close. Yeah, this is a half. Thank you. So a half, then I need to divide it by -2. So dividing it by -2 gives a -1/4. That definitely works fine because now our value of b, we can say -1/4 here. This is going to give us a +6/4, of which b, yo, what is the value of b? What is the value of b? Height b is going to be like 3/2. So we have the equation, but we don't need the equation. All we need is what we have now. We said the x value was a 3, right? The y value we can just sub 3 into the equation of the graph. So the equation of our graph, we said here it is y is equal to -1/4 x squared plus 3/2x. So let's just see if this is going to give us, let's see what this gives us. You throw at the x value of 3, right? 3/2 x value of 3. So from here, 3 squared is going to give us a 9. So that's like -9/4. And then here 3 times 3 is like 29 again. Wait, whoa. What's going on here? Sure. 3 times 3. Oh no, this is going to be 9/2. So you're going to multiply by 2/2 here. You're going to get yourself -9 plus 18/4, which is like 9/4. That's the y value of h. So therefore h, x value is a 3, y value is 9/4. Whew. Yeah. So you can see we kind of went in a circle a bit, but this is to give you the idea that when you do your math questions, you just need to have rhythm. If you can at least have rhythm, you're good. The moment you don't have rhythm, that's when you start to panic and doubt yourself and all that. But this is our answer. Let's keep things moving. It says here, quadratic function, right, has the following properties. Okay, looks fine. We have specific properties here to consider to form our question. So let's see what we have. It says, if you throw in a value of x minus p in the equation, it's going to be the same as if you throw in a value of x plus p. This is for all real values of p, okay? Then they said here, if you throw in this value, your outcome is a 2. So fortunately, remember, this is the x value of the turning point. Don't take stuff like this for granted. Because remember, the x value of the turning point is minus b over 2a. So this is telling you the turning point. You see? Because if you throw in x value of this is the y value that's coming out. And then they said b squared is smaller than 4ac. So if b squared is smaller than 4ac, what it means is, let's see, x is equal to minus b plus minus b squared minus 4ac over 2a. So fortunately, if b squared, which is this value here, if it is smaller than 4ac, it means that this number minus this value is going to be a negative value. So it means that your roots are non-real. Non-real. If your roots are non-real, it means that your what you may call your graph has no x-intercepts. You see, no x-intercepts. It means that our parabola, wherever it is, it's either smiling like this, where it has no x-intercepts, or it is either frowning like this or something, where there are no x-intercepts. That's what this last statement means. You see, because if this number is smaller than that one, it means this minus this is going to be a negative value, which does not produce any solutions. So they said you draw a rough sketch of f, labeling the turning point clearly. So the only thing with this kind of a question is we have to figure out what a is going to be, whether it's a smiling value or a negative value. So drawing a rough sketch, that's kind of interesting. So this is saying the y value is a 2. So if the y value is a 2, right? Or the turning point is at positive 2. If the turning point is at positive 2 and our graph has no x-intercepts, it means that our graph has to be smiling. You see?
because if it's not going to touch the x-axis, the only way it cannot touch the x-axis and still smile, no, the only way it cannot touch the x-axis is if what you may call is if it's a smiling graph instead of a frowning one. Okay, so the key thing with this kind of equation is obviously we know it's going to be smiling, as we said already. Now you may be wondering what this is trying to tell you. Remember, this is saying if you throw in a specific value, you're going to get a y value as an outcome, and if you throw another x value, you're going to get the same y value as an outcome. So this is trying to give us an idea of 2 points on our graph, right? So already our rough sketch, right? Let's just extend this. Our rough sketch, they said here, what we need to know is our rough sketch. You either need to think yourself, is it going to be smiling like this, where the x-intercept is there, and the other value is like the graph is more towards the right, or is your graph going to be more like this, where your graph is more to the left? So to do that, you can just try and make use of your turning point. So your turning point, what you need to keep in mind is, if this number is coming out as a positive 2, you have to remember that we don't know what B is. B can be a plus or minus. We don't know what A is. A can be a plus or minus. So if our graph has no real roots, let's see here, a value of B is smaller than 4A. See, yo. It looks like this is the only thing that we can try and use to help us, you know. So us using that, we just have to be a bit careful, because I mean, you may be thinking how we're going to get that information, because it's like, yeah, it doesn't seem like it's coming cheap. It is a formal question though, so we don't want to overthink it for any reason. We don't overthink it. But hey, this is good to this for all real values of p. Yeah, this statement, there's definitely something here. I just cannot put my finger on it, but let's just try and see what we can do with it. Okay, so it basically means, oh yeah. If this is a specific x value, right, and this is a specific x value, it just means that this is an x value somewhere on the graph, and this is an x value somewhere on the graph also. They have the same y value, you see. So if that's the case, you have to remember your turning point is always in the middle of two values on your parabola. Your x value of your turning point is always in the middle of two values in your parabola. So what you already know about your parabola is that the value where the x value is 6 minus p, it's going to be like on the left here. The 6 plus p is going to be on the right here, potentially, or vice versa. It doesn't matter. All we know is the middle of those 2 points is the x value of the turning point. So let's see here. 6 minus this, right? If you add 6 plus p and you divide by 2, that's going to be the x value of the turning point. 6 plus 6 is a 12, minus p plus that goes away. So you have over 2, then this is like 6. So what you know is the turning point is somewhere at 6. So somewhere at 6 here, you can have a turning point. And we have the y value of the turning point also. So the turning point is like somewhere here. And we said our graph is smiling. So it's going to be smiling like that and like that. So this point, we have x value 6, y value at 2. So from 6 going to the left here, well, whichever way, what we need is a y-intercept now. So for us to get a y-intercept, we obviously need to be a bit careful. So us being careful, I mean, whichever way, right? What can we now do? It says here, sketch the graph, labeling the turning point clearly. So all we have to do is to label the turning point. I'm like, they didn't say anything about labeling anything else. So we might as well just label the turning point, because that's the only thing that they want us to label, really. But then, since we have the actual value of the turning point, the x value is a 6 here, the y value is a 2. What can that help us with? This should be enough. I really don't think we need any other piece of information for this
for this equation. You see, we really don't necessarily need it. Yeah, we really don't. But if we had if we had to, let's say, get the x-intercept also, I mean the y-intercept rather, you'd be thinking to yourself, okay, fine. What you know is this point and this point, the y value is the same. So I mean, like, if this is a positive number here, right? P, this and this, if P is a positive, I mean, judging from the question, they only ask for the labeling of the turning point and our shape. So we have our shape labeled the turning point. This should be good enough. This really should be good enough because you only need the y value of the turning point, the x value of the turning point, the shape, and your y-intercept needs to be above the turning point. So those are where you're going to get your marks. If you do find a value for this, I guess that's just a bonus, but for now, it's really not necessary. So let's move on. Let us see. Question number 10 here. What does question number 10 say? Question 10 says, in the diagram below, you have a cubic function, and then you have a straight line graph. They said F and G intersect at A. And then it looks like we have another line. This other line here, we don't know what it is. It's H. They didn't say anything about H, but they said H is a tangent at A. And then it says, then calculate the coordinate of the x-intercept of H for 9 marks. So you see, this is what I was saying. If you are a CAPS learner, the only difference with IEB questions sometimes is they just need you to do a lot of things for one question. They don't like hint you and ask you small questions first and then a big one. They just ask the big one and they just make all the marks together. That's the only difference with your CAPS and your IEB papers. So let's just carry on from there. Carrying on from here, yeah, let's read again. They said h of x is the tangent at A. Calculate the coordinates of B, the x-intercept of H. So it looks like if you can get the equation of H, getting the value of B is going to be very, very easy. So let's just get the equation of the tangent to the curve. That's literally all they're asking us here. They're asking us to get the equation of the tangent to a curve. Once we get the equation of the tangent to this curve, we can just get what they're asking for. That's why you see I'm saying IEB, it's not harder. They're just asking one big question without asking smaller ones first. So anytime you need an equation of a tangent to a curve, there's one thing that the curve and the tangent share. As I've said already, they share a coordinate, right, which is a x and a y value. What they also share is a gradient at a specific x value. So for a specific x value, they also share the gradient. And this will be the same x value that you throw over here, the same x value that you throw over there. Those are the two things that the tangent and the curve share. So what you know is the tangent and the curve meet here. We can get this point here by making f and g equal to each other. So let's do that first. But before making f and g equal to each other, no, actually let's do it because it doesn't seem like it's a difficult thing to do. It actually looks like it's a straightforward thing to do. So let's do it. So here, f of x equal to g of x. We're going to have here x cubed minus 5x squared, right? And then you have minus 5x squared, and then you have like plus 3x, and then plus 9 equal to 3x plus 9. So the 9 and the 9 will go to the same side, they'll cancel each other. You have x to the power of 3 here minus 5x squared plus 3x. The 3x and the 3x will also cancel each other because this is a plus 3x. You're going to take it over minus 3x. This is going to give you a 0. Now you can factorize x squared, x here minus 5 equal to 0. You have x squared equal to 0 or x minus 5 equal to 0. It means that your x is a 5 or your x is a 0, which makes sense, you see, because you have 2 points where these graphs meet each other. The first point here is where x is a 0 clearly. The other point here was clearly seeing that the x value is a 5. The y value we don't know, but we're about to find it. Getting the y value there, which is obviously necessary, because we're trying to get as much information as we can from this sketch to eventually get the equation of h. Getting the y value, we can throw it into this equation of g here. Y value is a 5. Put a 5 there. 5 times 3 is a 15. That's like 15 plus 9. And then you have like 24 as the answer. So now you have a coordinate that the graph and the tangent pass through. What's important is actually the value 5, because the value 5 is the same 5 that will get you the gradient at the point where they meet. Because if you get the gradient here at the point where they meet, it is also the gradient of the tangent. The reason we need that is because if you want the equation of our tangent, right, the standard form of any straight line is mx plus c. So we need a gradient and a y-intercept. Apart from needing a gradient and a y-intercept, fortunately, we can use this format. Y is equal to, x minus x1 is equal to m x minus x1. So we have to get a gradient, and we need a coordinate that the graph passes through. So a coordinate we have, right? It's only the gradient that we still need to find, of which the gradient we can find it easily from what we're about to do. We just want the gradient at this point. So getting the gradient at this point, we can use our first derivative of our cubic function, because remember, our cubic function, if you want to find out any gradient at any point, what you do is you take your first derivative and you make it equal to a 0. So let's take our equation of f of x, right? This is what f of x looks like. We want to differentiate it and make it equal to 0 and solve for x, so that we can find the x value where you have a gradient of a specific number. So we want to find the gradient where the x value is a 5. That's going to be the gradient of our tangent. So to do that, let's just create ourselves some space here, because we have just been too reckless. Let's move this over here. Move this over here. Move this over here. So differentiating once here to get our gradient equation, we're going to have here 3x squared minus what? Minus 10x plus 3. If you make it equal to 0, you know that you want a gradient where the x value is a 5. So where x is, you put a 5, because that's the x value for which you're looking for a gradient. No. X gradient is not equal to a 0. You're looking for the gradient where the x value is a 5. So gradient is left open. And then you have x value a 5, because you're looking for a specific gradient. You don't want to get where the gradient is a 0. The gradient is a 0 here, and the gradient is a 0 here also. But those are not that's not what you're looking for. You're looking for the gradient here. So you don't know what the gradient is. So you leave this one open, but you know it's at an x value of 5. So all this 5 squared is 25 times 3 is 75 minus 50 plus 3. The gradient at 5, let's see, 75 minus 50 is 25 plus 3 is 28. There you go. So does that make sense? Yep, we have our gradient there. So once you have your gradient at that point, you automatically have the gradient of the tangent that you are working with, you see. So once you have the gradient of the tangent that you're working with, you're home free, because now you can find out this information, you see. So y minus y1, the y value is 24, remember. Gradient, we have found it as 28. X value, we got it as 5. So this is going to give you the equation of your tangent. So getting the equation of your tangent, 28x minus, it's a big number, eh? Let's just break it. Break it what? I need a calculator. Calculator, help me, please. Because I don't want to do mental math. Let's see, 28 times 5, right? 28 times the 5 there, going to give you 140. Negative 140. Then this is y minus 24. the 24 goes over, you would add it, right? So you adding it, you'd have 28x negative this plus this, right, gives you a negative 116. There you go. So this here, you want to get the x-intercept. So you make y a 0. So y becomes a 0 here. 28x minus 116. This is like positive 116. And then this is 28x. So you're going to divide both sides by 28, 28, 28. Our x value is equal to 29 over 7. So yeah, that is quite a distinct answer. But you can see that our question is definitely does not pulling any punches. But it looks like an equation. You can see that that's what I'm trying to say with IEB. IEB, they just ask one big question all at once instead of like leading you on by asking things like they could have easily maybe CAPS would have maybe said get a coordinate of A as one question. Then CAPS would have said get the equation of the tangent only, and then they'll make that a 4 and a 5 mark question. But here IEP they just put it all together. That's the difference you see. You can see none is harder than the other. But anyways, you have x, they want the coordinate, right? So you have to say therefore x value and then y value. That's the coordinate of B as they are asking. So it is all good. Let's move on. They said here B. It says the following information is given, right? You have this is a first derivative. So this is a gradient equation. Now it says here in the original equation, right? The y value is 0. This equation here, if your y is equal to 0, this has a negative real solution. So whatever this is going to sketch a parabola, which is the first derivative. It means the original equation is actually a cubic function, you see. Ax cubed plus bx plus cx plus d. This is a parabola. It's a smiling parabola, you see. So these y values would be representing the gradients of this graph. Now they told us that this cubic function, right, whatever it is, it's a positive cubic function. It has one negative real solution. So what that means is if your first derivative is smiling, it means that your original graph also goes up, down, and then up again. So if it has one negative solution, it means that this is saying if you solve for x, right, and you make y as 0, your graph is only going to touch the x-intercept once, and it's going to touch it on the negative side of your Cartesian plane. So you're going to have maybe something like this, where your graph does not touch your x-axis again. It only touches it once on the negative side. So this is a rough sketch of your image. All this is based on the theory that you need to know about all this work. Now, if you sort of like looking at what we're doing now and you're asking, bro, how did you just do all that? You can easily look at, for example, something that's on the main website, on the main YouTube channel rather. On the main YouTube channel, there is an application of calculus, playlist. In that application of calculus playlist, right? The one thing that is definitely clear there is there's a tutorial here. It says graph of the derivative of a function. You can see here, this tutorial, it basically touches on how the parabola, or how it touches on how if you have a cubic function, right? You can differentiate it and you'll have a parabola, and then differentiate it again, you'll have a straight line. And it basically talks about how all these are linked together. So you can watch that. But obviously, if these kinds of questions are also a bit difficult, right, then it means you need to sign up for the online courses. The online courses on the website, as of this recording, you have a huge sale of 99 Rand only. So obviously you can just hop on there. If you're in grade 11, this is going to help you also, especially if you're doing IEB, because the idea is 70 to 80% of all this work is grade 11 work anyways. This gives you access to all the online courses on our website. You can see here it's an application of calculus course, and it's on sale from the 23rd of October until the 7th of November, depending on when you're watching this. But anyways, this is what our rough sketch looks like without a doubt. For 4 marks, it said for what values of x is f of x.
increasing. So your graph is always increasing where your y values are going up. So the two things that you have to look for is the two turning points. So what I mean by that is, if you're walking on this graph, as long as you're walking like upwards, the graph there is increasing. You see, you're walking upwards, so the graph is increasing. Here also you'll be walking upwards, so the graph is also increasing. So it's increasing from your one x value of your turning point to the other x value of your turning point. So we may not know where the y intercept is, but let's just leave that out for now. So this is where your first derivative is going to come to bail you out, because clearly we need the turning points. Fortunately, to get the x values of the turning points, we need the first derivative, and you need to make it equal to a 0. So let's make our first derivative equal to a 0. The reason why we're making our first derivative equal to a 0 is because we need the x values of our turning points. If we get the x values of our turning points, we can say the graph is increasing from this x value going to the left and from this x value going to the right. So let's solve for x. The 4 can go over. At this point in time, you have to be careful to definitely put the plus and the minus when you put stuff in under a square root. Otherwise, you will not get two answers, and that's going to be a problem, you see. So here, your two answers, you have to start one where you use a positive 2, the other one where you use a negative 2. So that being said, the one goes over, you have x as a 1. The one goes over, you have x as minus 3. Hence why you see I left out the y axis, because it was going to ruin things. But let's see, this x value is a negative 3, this x value is a positive 1, you see. So answering your question is definitely going to be a bit easier because of that knowledge that you have, you see. So here you're going to say your x values are smaller than negative 3, or those same x values are bigger than 1. Nothing crazy, nothing major. You're going to get 4 marks. Your theory is important, you see. So you can see IB just has deeper questions, but the content and the knowledge is the same. Here, 2 says use the information above to sketch the graph of f on the same set of x's below. Label the x values of the turning points and the x value of the point of inflection. So the x value of the point of inflection is just an x value that is in the middle of our 2x turning points. So I mean, like, we have already done this question in the previous one. So this is 5 marks. It's going to be easy 5 marks because we already drew the graph to help us work out what we were working out. So this graph, since our turning point is at, let's say, like negative 3, right? Obviously, we're going to maybe move our graph something like this, because it should not touch the x-axis twice. So this is what our image looks like. You see, we already stated that one of our turning points is at negative 3 here, the other one is at positive 1. The point of inflection is going to be in the middle of your two x values of your turning point. So you're going to find the middle of negative 3 and 1. So you add those up, you divide by 2. It's going to give you negative 2 over 2, which is like negative 1. So there you go. See, this is a negative 1. So that's quite straightforward. They just want us to get that. They said we should label the x values of the turning points. We did. And then the x value of the point of inflection. We did. And then we should just draw the sketch. We did. You see. So you're going to get your 5 marks here without worrying about adding any unnecessary piece of information. You see. So as long as you show your negative 3 there, you show your other negative, your positive 1, and all those other stuff, you're good. Now, they didn't say anything about what you call, what did they say? They didn't say anything about anything else. You see, you have a graph here where you have a negative x-intercept, yes, and that negative x-intercept, it clearly does not need to be labeled because we don't have that value. And then the turning points that we have labeled them. We've labeled the x values. and we've labeled the x value of the point of inflection. That's all you need. Anything else that you may see on this sketch, wherever you will be seeing it, it's just extra information, and we really don't need that, you see. So let's move on. Question number 11. What does question number 11 say? Question number 11 says, a farmer draws a rough sketch of the two adjacent fields he needs to fence. So he has two fields, field number one and field number 3. He needs to put a fence around both of them. He needs to put a fence around both of them, you see. So him putting a fence around both of them, it says here, a farmer draws a rough sketch of the two adjacent fields he needs to fence. Field A is a square with a width of 6. So if it's a square, you have to remember that this is x, this is also going to be x, this is also automatically x, this is also automatically x. Don't take for granted those pieces of information, and this is also automatically x. Then it says, let's see here, the field B is a rectangular shape with a width of y. The area of field A, plus the area of field B is 1,000 units squared. Then it says here NR, which is from N going to R, is the only fence that is shared by both field A and B. Then it says write y in terms of x. That's a very easy question because you have the area of field A, right? Which is just going to be, let's see here, area of A is just x times x, which is x squared. The area of B, they told us it is just y times x. The thing now is, if you add them up, you get 1,000. So x squared plus xy is 1,000. The reason why I say this was a straightforward question is because anytime they want you to write down something in terms of another variable, it means you need an equation. Now, your own description has given you an equation here. So you use that equation to get something in terms of x, as in a value of y in terms of x. So what you do is you can isolate, it looks like, let's see, what can you do here? You can take the x squared to the other side, it becomes a negative x squared. Divide both sides by x afterwards. You can have y is equal to 1,000 minus x squared over x. If you want to simplify, you can have 1,000 over x minus x, because x squared divided by x is going to be x, and then y is here. So you have your equation in terms of you have your equation of y in terms of x. It's quite a straightforward example here. So you need to know how to do these kinds of things very easily. Otherwise, your life is going to be a bit hard, but all this is nice. It's okay. So here they now said, calculate the value of x so that the minimum amount of fencing is used. So this question and the previous one, they could have just made it in one equation for 8 marks because that's the nature of IEP. But funny enough, they've split it up. That's very interesting because that's what CAPS would have done. But you can see there's really no difference in the syllabus. Everything is the same. The level of intensity is literally also the same. We have all the proof here. Anyways, so if you're going to work out the value of x where the fencing is a minimum, what you need is, if you need the minimum of something, you need an equation of whatever they're talking about. So we need an equation for us to see how much fencing is needed. Once we have that equation, right, that will give us the fencing needed. We take that equation, we get its first derivative, right? We get the first derivative of that equation, and then we make it equal to 0. That's what we do. We need an equation for the amount of fencing needed. We differentiate it, we make it equal to 0. So the amount of fencing needed here is obviously going to be x plus x plus x plus x plus x here, plus y, and then plus y. So that's the amount of fencing needed, you see. So let's start there, The fencing needed, right? The fencing is going to be equal to 1, 2, 3, 4, 5x, and then plus 2y, you see. 5x plus 2y. Now this equation
you're better off having it in terms of x so that you can differentiate it and equate it to 0. This is where this comes in, you know. So wherever you see y, you're going to throw there 1000 over x minus x. And that equation is going to be in terms of x now. See, so 5x plus 2. And then you have this here in brackets. Put that there. And then here, you have the 5x. If you multiply inside, right, you're going to have 2000 over x. Multiply again, you have negative 2x. This is f of x. The fencing, this is the equation for the fencing. If you simplify it, you can have 3x plus 2000 over x. Now you have an equation for the fencing needed. Remember, we said you cannot get its first derivative, make it equal to 0, and so for x. That's the way you do these kinds of questions. So before you differentiate this, you have to put it in a format that we can actually differentiate. So to do that, anytime you see a fraction like this one, right, you have to take this x to the power of 1 next to the 2000. But then when you do that, the exponent has to become a negative. You see, this has not been differentiated. You have just simplified. When you now differentiate, now you need to show the symbol here. You see, the first derivative symbol. You see, the first derivative symbol. Now let's differentiate. 1 times 3 is a 3. 1 minus 1 is going to be a 0. X to the power of 0 is a 1. Here, negative times 2000 is negative 2000. Moving 1 from the exponent, you're going to get a negative 2. Now this, you need to make it equal to 0, you see. 3 minus 2000, x to the power of negative 2. Fortunately, you don't have to worry about the negative 2 there. This can just go over to the left side. It becomes a positive 2000 to the power of negative 2. Remember, moving it to the other side does not affect the exponent. It only affects the value here. It affects the sign here. So you're going to divide both sides by 2000 here. And then obviously now you can just solve for x. Solving for x here, you just need your calculator. Because in your calculator, all you need to do is you literally just need to, you can literally just put a negative. You can just do this in your calculator. Now, okay, an easy way is you can actually, there's a 1 here, right? You can take this value under the 1. The exponent becomes a plus. And then since you want to solve for x, you can now just cross multiply. You have 2000. This times 3 is that. Divide both sides by 3. You have 2000 over 3, which is x squared. Square root both sides here. X is equal to square root of 2000 over 3. The reason you're not going to need to put plus or minus here is because distance cannot be a negative, you see. So if you put this in the calculator, it's also giving you 25.82. That's your minimum value of x. And this is the nature of these kinds of questions. You need the equation of whatever they're talking about. Once you get that equation, you need to then make sure it has a single variable. And then you have to differentiate that equation. You make it equal to 0, you get whatever they're asking for. So let's move on to question number 12. Question 12 says the following. It says the 5 cards given below are used by players in a game to create 5-digit codes. These 5 cards are fixed, obviously. And then they said here, a few examples of 5-digit codes that are created or that can be created with the cards above are these values here. There are no repetition allowed because obviously once you use a card, it's gone. Then it says how many unique 5-digit codes can be created. So this is a straightforward question because there are 5 slots, right? Slot number 1, slot number 2, slot number 3, and 4. So what happens is when you have all your cards available, you have 5 options for the first slot. So the moment you put one card here, you only have 4 options left for the other one. When you put one there, you have 3 options left. When you put one here, you only have 2 options left. When you put one here, you only have 1 option left. And then for 2 marks here, no, we're not done. So the number of options here is going to be 5 times 4 times 3 times 2 times 1, which is 120. I literally recorded this question just now, but I forgot to press record. But for 2 marks, it says here how many unique 5-digit codes starting with a number can be created. What you do is you lay out 5 slots again. Slot number 1, 2, 3, 4, and 5. If it has to start with a number, then what you do is in the beginning here, you only have 3 options, right? Which is just 1, 2, or 3. You only have 3 options for the place here. Once a number goes here, you only have 4 things that can potentially go here. Once you put something there, you only have 3 here. Once you put something there, you only have 2. Once you put something here, you only have 1 option for the last slot here. Those number of arrangements, you can just multiply all these numbers. It's going to be 3 times 4, which is 12, times 3, which is 36, times 2, which is 72. That's the way we like it. Question number 3, though, says, what is the probability that the 2 letters will never be next to each other in the code? So if you want to find out the probability that your 2 letters will never be next to each other, right? You need to keep in mind that these kinds of questions, if these kinds of questions are still a problem for you, then you definitely need something like the probability course on our website. But fortunately, as already said, right, within the sale that's currently ongoing between the 23rd and the 7th of November for the all access pass, it gives you access to everything for just that single fee. And the probability course is amongst that. This is amongst the topics, you see, because if you check the probability course layout, there's probability, general probability, where you'll be working with, the addition rule, mutual exclusive, and all that. And then you have tree diagrams, Venn diagrams, two-way contingency tables, and the fundamental accounting principle, where you can see the different kinds of lessons here: seating arrangements, letter arrangements, codes, generation, and all that is what you will be learning in the probability course. In total, this is about 3 hours long, so you'll be able to go through it in like one day. But anyways, let's see here. What is the probability that the 2 letters will never be next to each other? So if you want the probability that the 2 letters will never be next to each other, a situation like that, right, you actually have to work out a scenario where all the codes are where you have to work out a scenario where the letters are actually next to each other. You want to find out how many arrangements are there where your letters are actually next to each other. Once you find out the total of that, you remove it from 120, because 120 is all the arrangements without any restrictions. So if you take 120 and you remove all the arrangements where the letters are actually pasted together, what you have left in that calculation is the ones where they are never next to each other. You see, because if you take all the arrangements minus the ones where A and B are together, your remainder is where A and B is not together. So let's see where the number of arrangements where A and B will be next to each other, because those are the letters in the codes. So what you do is you visualize your A and your B pasted together, right? Now, the number of arrangements where this is pasted together, you can technically arrange your values here in 1, 2, 3, 4 factorial ways. These 2 that are pasted together, they can only be arranged in 2 factorial ways. So that being said, the total number of arrangements here is 2 factorial times 4 factorial, which is just going to give us 48. So these are the arrangements where the A and the B are next to each other. You see? So now to get the number of arrangements where the A and the B are not next to each other, you're going to say 120, right, minus 48. You're going to get a total of, what is this here? I think you're going to get 72. Yeah. So now you're going to know that the number of arrangements where they are never together, it's 72 options out of a total of 120. So that being said, this is the probability that you get A and B never together, because it's 72 of options like that over a total of 120. This simplified is just 0.6. It says you have 3. As of this recording, the All Access Pass, which allows you to access everything on the website, is currently on sale. The sale will give you access to the online courses for a total of 60 days. Now, the All Access Pass includes the entire syllabus, everything for paper 1, everything for paper 2. You have video lessons that are preloaded on the website, meaning that you'll be able to go through
all these video lessons at your own pace, at your own time, without worrying about anyone necessarily scheduling any sessions. Now, the link in the description will take you to the course website where you'll be able to make a purchase of this bundle. The sale is ongoing between the 23rd of October until the 7th of November. Depending on when you're watching this, I suggest that you hop onto the course website and make a purchase. You can purchase directly on the website using a credit card, debit card, or you can make a purchase via the EFT details that are provided on the website. As a reference, you should put in your name and your surname and send the proof of payment to the email address listed on the screen. For more queries, questions, you can always just contact us via WhatsApp. If you would like to find out more information about Bright Young Brains, you can always just Google us and you will be able to find more information regarding what it is that you would want to find out. Depending on where you're currently residing, you can always just contact us via the contact details that you see on the screen. Six-sided die that you use to create a geometric series by randomly throwing the die. The one die is red, the one die is blue, the third die is green. So I think they meant to say the one die is red, the second die is blue, and the third die is green. And then they said here the number on the, what do they say here? The number on the what? The number on the red die represents the value of the first term in the series. You then take the value of the blue die and divide it by the value of the green die, generate the common ratio. Then he says, what is the probability that if you sum the series to infinity, it will converge on the number 10? Wow. Oh yeah. This question just makes me laugh because obviously the whole thing is just a bit crazy. But without worrying too much about it yet, the one thing you can obviously definitely do for yourself is generate the sequence, see what the sequence looks like, and then once you've gotten what the sequence looks like, you can delete the rest of the question. So this sequence says the number in the red die represents the value of the first term in the series. Okay, so the number in the red die, we don't know what it is, right? But then it says here, you then take the value of the blue die and divide it by the value of the green die. Whew, generate the common ratio. What is the probability that if you sum the series to infinity, it will converge on the number 10? Hi, man. This question just seems so crazy, bro. It literally doesn't seem like it even makes sense. It literally doesn't seem like it makes sense. But obviously, I'm like, the only thing there is to do is to read it from the beginning. It says you have three six-sided die, right? That you use to create a geometry series by randomly throwing the die. Okay. Then it says the one die is red, the one die is blue, blah, blah, blah. Okay, yeah. So the thing is, what we can safely say is, right, from, let's say T1 here. T1, whatever T1 is, it is either the number 1, 2, 3, 4, 5, or 6. Right? It's a number either from 1 to 6, guaranteed. And then what we do know is the second number is going to be what do you call, the second number is either going to be, it's going to be a number that is generated by taking whatever green is divided by whatever let's see here, they say here you take the value of the blue die and divide it by the value of the green die to generate the common ratio. So the idea is if this sequence has a sum to infinity, right, whatever happens, the common ratio has to be bigger than -1 and it has to be smaller than +1. There's no other way. Meaning that the common ratio can only be something like 1/6. It can be something like 2/6, 3/6, 4/6, 5/6. Right? It can only be one of these numbers. but obviously it can also be something like 1 over 2, 1 over 3, 1 over 4. Going on, excuse me. Yeah, so R can be a lot of numbers, but it just means R just has to be a number between -1 and 1. So yeah, this question is definitely a bit crazy. The only crazy thing is, the only other crazy thing is that there is no mark allocation. There's no mark allocation. The mark allocation is what is this, is left out, of which the mark allocation would have made life a bit easier, like literally. So there's that. Yeah, this is just crazy, bro. Anyways, so I've only just looked at this question for like a few seconds, and without overthinking it, I think the idea is to just work backwards. So working backwards, they asked you what is the probability that if you sum the series to infinity, it will converge on the number 10. So what you already know is if your sum to infinity is 10, right? This is what we have. Your sum to infinity is equal to 10. If your sum to infinity is equal to 10, just redo this nicely. Sum to infinity equal to 10. It just means that 10 is equal to a over 1 minus r, because remember, the sum to infinity formula says that a over 1 minus r is what you have as your the sum to infinity. So if they say what is the probability that the sum of the series infinity will converge on the number 10, for it to converge on the number 10, right, we have to find out, we know that a has to be a certain number, and then r has to be a certain number also. But the one thing that we can do is a can only be one of 6 numbers. That's what we know. R can be multiple values, but let's see what we can do. In this situation, I mean, like, funny enough, you would be thinking to yourself, why don't we just put in values for a, like 1, 2, 3, 4, 5 until 6, and then just get multiple values of r? Well, we could try that. Let's just try that and see. Let's try where a is a 1. If a is a 1, then your value of r is, let's see, cross multiply here. You're going to have 1, this bracket here times this here times 10, right? It's going to be 10 minus 10r. Then so for r, this is going to go over. You're going to have 10r here. It's going to go over. You're going to have 10 minus 1. This is like 9. 10r here. If you divide by 10, it's like, let's see here, r can be, what's it called? R is 9 over 10 if your value of a is a 1. But the thing is, this here is a value that is somewhat almost, we cannot necessarily have 9 over 10. It's not a valid option because the numbers on the die is numbers from 1 to 6. So you cannot have any value that is going to give you 9 over 10 in its simplest form. But anyways, let's try a as a 2. If a is a 2, let's see, we're going to have 3 here, 1 minus r. We're going to cross multiply as we said. 1 times 2 is a 2. 10 times this bracket here. That's 10r. If you move the 2, you're going to get 8 here. And then here, your 8 over 10. Let's see what this gives us. This is going to be 5 over 4. Yeah, this is a valid R value. And you may be thinking to yourself, but where is this all going? Like, literally. Because we're going to do this like 4 more times. But, I mean, I don't know. This is more like a last week kind of approach. But let's see. 10 here. If A is a 3, 1 minus R. 10 minus 10R equal to 3. And then this is going to be like 10R, 7. 7 over 10 is not a valid option for R, but then the others, let's try, we have 4, 5, and 6. So if A is a 4, let's see what this gives us. 10 minus 10R is equal to 4. Then here, 10R, this goes over, that's like a 6. And then here, that's like 6 over 10. is like r. This in its simplest form is 3/5. This is another valid option for r, right? And then if you try out 5, you're gonna have 5 over 1 minus r, right? 1 minus r. And then here, if you cross multiply, as we said, you're gonna have 10 minus 10r, and then 5. This is gonna be 10r. This goes over, maybe 5. 5 divided by 10 is a half. That is definitely a valid option, because to get a half, you could easily have had 3/6 as your combination. And then we have one more to test out, right? Which is 6. So 6 is like 6 over 1 minus r. And then if you cross multiply, you're gonna have 10 minus 10r. The 6 here. 10r here, the 6 goes over to the left. That's like what? 10 minus 6, right? That's like 4. And here you're gonna have 4 over 10. Then you're gonna have 2 over 5. So out of all these options, right, because a can only be one of 6 numbers. So we said if a is a 6, right, this has to be the value of r. So your sum infinity to be a 10. If a is a 5, this has to be, if a is a 5, this has to be a value of r. So your sum infinity to be a 10. If a is a 4, this has to be your value of r. So your sum infinity to be a 10. This one does not qualify because we cannot, in our options, right, for the numbers on our die, we don't have a 7 or a 10 or anything that can give a 7 over 10. This one is valid. So we know that if a is a 2, this is what would cause us to have a sum infinity of 10. And then the 1 doesn't work. So there's only 1, 2, 3, 4. 4 values of r that produces sum infinity of 10. So let's see. If you read the question again, what is the probability that if you sum the series infinity, it will converge on the number 10? So the probability that it will converge on the number 10, I mean, you may be thinking to yourself, okay, fine. Technically speaking, right? You have to now think to yourself, okay, fine. You have to ask yourself, what is the probability that you get the number 6? Well, you have to ask yourself this scenario, right? You have to ask yourself, what is the probability of getting a 1, 2, 3, 4, 5, 6? So the probability of getting a 1, a 2, a 3, a 4, a 5, and a 6, all these are equal probabilities, right? There's 1/6 chances, 1/6 chances, 1/6 chances, 1/6 chances, 1/6 chances, 1/6 chances. After all this, you have to think to yourself, the probability of getting a 1, after getting a 1, you have to ask yourself, what is the probability of getting what you may call yo, this is actually kinda crazy. The reason why I say this is kind of crazy is because after getting a specific value for a, right, your common ratio, you have to think of it as, you have to think to yourself that your common ratio is, as we said, it is determined by the, so what is this? The blue. They say it is determined by the blue die. It says that you then take the value on the blue die and divide it by the value on the green die. So the thing now is, we would need to be asking ourselves, okay, fine, after getting, oh, the options are all these numbers, so 1, 2, 3, 4, 5, 6. We said that of these 6 options, there's only 4 that can ever take us, to the promised land, for lack of a better word. 6 can take us there, 5 can take us there, 4 can take us there, and then 2 can take us there. So the idea now is we would be thinking to ourselves, okay, fine, we have all these numbers as options, but then now, what are the different probabilities of our different values for r? Because the combinations, right, of our value of r, there are just so many. Because you can have 1/1, 2, 3, 4, 5, until 6. And then you can have what you call 2 over 1, 2, 3, 4, 5, 6. Then you can have 3 over 1, 2, 3, 4, 5, 6. Then you can have the combinations are so many. But let's just see how many combinations we can actually have for our value of r. Let's find out how many combinations we can have for our value of r. I guess this is where, even the fundamental counting principle may come into effect, because we need to find out how many combinations of r we can potentially have. So what you can do for yourself is you can ask yourself what to find, logically speaking, right? You can almost think of these as like, yeah, this is good. This is actually kind of crazy, because you wanna think to yourself, fine, you can have 1 over 1 to 3 over 5, 6, 7, 8, 9. I mean, you can have 1 over 1 to 3 over 5, 6. You can have 2 over 1 to 3 over 5, 6. You can have 3 over 1 to 3 over 5, 6. You can have 4, and then 5, and then the 6. And then you can have it the other way around, right? Where, no. Let's put it this way. The 1, right, you can have it over 1. You can have it as 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, or 1 over 6. And then a 2 can also be over 1. And then it can also be over 2, over 3, over 4, over 5, over 6. And then the same happens for the 3, and the same happens for the 4, same happens for the 5, the same happens for the 6. All these will get a chance to be over all these numbers from 1 going to 6, from 1 going to 6, from 1 going to 6. All these will all get a chance to become, they'll all get a chance to be over 1 going over 6. So if you think of the total number of r values that we have, right? You can see here there's 1, 2, 3, 4, 5, 6 of them, and then there's 6 of them, right? And then there's technically 6, 12, 18, and then we have like 24, and then we have like 30, and we have like 36. So there's like 36 values of r that are possible. You see? Now, the one thing you want to think to yourself is you can either get 1, 2, 3, 4, 5, or 6, right? So after getting each of these numbers, say you got a 2. After getting a 2, there are 32 options, right, of r values. But regardless of us having 32 options, of those 32 options, there's only 4 that would no. Of those 32 options, right? The only one that would result in a sum infinite of 10 if you got a 2 is this one over here, which is like the 4 over the 5. And that 4 over 5, there's only one option like that out of 36. You see, there's only one option like that out of 36 that gives you a sum infinity of 10. So here, the 4 out of, let's see here, for a 2, right? We said 4 out of 5 will work. So 4 out of 5 will work, right? And the probability of getting that one is just 1 out of 36. Now, for the 4, we know that there's also a 1 out of 6. There's also a 1 out of 36 chances that we get 3 over 5. And then for the 5, there's also a 1 out of 36 chances that we get 3 over 36. Let's put this here. There we go, 3 over 36, right? Let's see here, 3 over 36. 3 over 6, there's only a 1 out of 36 chances that we get that. And then for the 6, if you got a 6 the first time, it's 1 out of 6 chances. But then now, for you to get a 2 over 5, for you to result in you getting a something of 10, the chances of that happening, as we already also stated, it is just 1 out of 36. Now, the funny thing is, oh no, yo. I think this one we have to consider, we have to reconsider this one, because there are multiple options to get a half. This, I mean, there aren't really multiple options to get 4 over 5. This, there aren't really multiple options to get 3 over 5. This, there really aren't multiple options to get 2 over 5. But then for a half, I mean, there are different combinations. I mean, like 4 over 5 gives a half, right? And then 3 over 6 also gives a half. Let's see, 1 over 2 also gives a half. 2 over 4 gives a half. 3 over 6 gives a half. So for the half, there's actually 3 options, right? Out of the 36 that, no, I think the wrong one. For the half, there's actually 3 options, right? That will give you, what you may call a fraction of a half, because the idea here is the fraction that's a half, not necessarily the number 3 over 6. This number just has to be a half, because as long as that number is a half, it will work out. You see, as long as r is a half, it will what you may call work out. So that's what we need to keep in mind, right? That our value of r, there are multiple times that it can potentially be a half. But then for the others, there aren't really a lot of ways that we can get those particular values. But yeah, so from there, we need to think ourselves, okay, fine. The probability that you get a 2 and then you get a 4 out of 5 as your common ratio, the probability of that happening is just 1 over 6 times 1 out of 36. And then the probability of getting a 4 and then this value, it is just 1 out of 6 times 1 out of 36. The probability of getting a 5 and then this value, it's just 1 out of 6 and then times 3 over 36. The probability of getting a 6 and then this value, it is just 1 out of 6 multiplied by 1 over 30. So, all that being said, right, the probability of this happening plus this probability plus this probability plus this probability, we have to add them all up after putting all those values into our calculator. So let me just grab this calculator. This is actually quite a very, very interesting question. Kind of weird knowing that it's going to the what you may call the IG page, but it's fine. I mean, like, it is worthy. It is worthy. Just a crazy question. But anyways, 1 over 6 here multiplied by 1 over 36. This is equal to 1 over 216. So 1 over 216. And then we have here again 1 over 216. And here we also have 1 over 216. No. First one is not going to be 1 over 216. Only the last one also just going to be 216. 1 over 216. This one, going to be to 1 over 72. 1 over 72. So, yeah, after doing all this hard work, this answer seems quite interesting, but the logic behind it is all there. So you're going to add up these probabilities. You see, 1 over 216, you have 3 of those, right? You have 3 of these ones. You have 3 of these ones, right? And then we're adding 1 over 72. So what does this give us? It gives us 1 over 216 times 3. Then we have here plus 1 over 20. That's going to be 1 over 36, which is quite awkward, but mathematics does not lie. So with all this being said, right, the probability that we get, I said here, what is the probability that if the sum to, what is the probability that if the sum of the series infinity, what is the probability that if the sum, or if you sum the series to infinity, it will converge on the number 10. So the probability that it will converge in the number 10 looks as though it is just 1 over 36. The reason for that is we said in the beginning, the probability of getting 1, 2, 3, 4, 5, or 6 is just 1 out of 50. But then for you to then get the sum to infinity of 10, it can only be specific values of r's after specific values on your die for the first die. So with that being said, I mean, because you're dealing with like different, when you say die, it's like a dice, but plural. But then the thing is, the point is, only 2 is the first number you get, and only 4 and only 5 and only 6 can potentially eventually get us a sum infinity of 10. But then for those numbers to do that, the value of r has to be a specific value. So we said for r, for this 2 to produce a sum infinity of 10, this is what the value of r has to do, and there's only 1 out of 36 chances that we get that. And then for the 4, we said the value of r has to be this number. And then we can only get this number 1 out of 36 times. And then for 5, for it to produce something of 10, the value of r has a half. Now for us to get a half, there are 3 options, 3 out of 36 options that we get a value of r of half. So 6, it has to go with this value of r. Now, if we are to get this value as a value of r, this is the probability of getting that. So we say the probability of getting 2, 4, 5, and 6 is just 1 out of 6, right? And then you have to multiply it with the probabilities of getting these numbers. So these are the probabilities of getting something infinity of 10, something infinity of 10, something infinity of 10, something infinity of 10. So you add up those probabilities, which gave us 1 out of 36. So this answer is quite low, quite cool. This could easily be an 8-mark question in an exam in my opinion. Because, yeah, it is quite interesting. But yeah, man, it's a cool question. Cool question.
So if you've gone through the full paper, big up to you. Now, obviously, all these kinds of tutorials that we have just laid out today, you need to do yourself a favor and sign up for the online courses on our website. Because the online courses on our website are the kinds of courses that are going to make you exam ready. If you need any assistance, if you need any questions based on anything that we have just worked on, you can just hit me up on IG. There's actually an underscore in between the LE here. You can just hit me up on IG, and then I'll be able to respond whenever it is that I can respond. But for now, I'll catch you in the next video. Cheers. But obviously, if you need to get an idea of what kind of papers are on this past papers channel, let's just give an idea of the kinds of papers that are on this past papers channel. So obviously, Bright Young Brains is the main channel. And then we have here our past papers channel. On this past papers channel, you can see here the kind of tutorials that you have. We post regularly. You can see this was just posted 20 hours ago, 3 weeks ago, 3 weeks ago, 3 weeks ago, 1 month ago. But anyways, these are full papers from start to finish without leaving anything out. You have 2022 papers, 2018, June papers, 2021. You can just see what you will have there. Anyways, that's that from my side. I will catch you in the next video.